Our last two sessions, we will have some flying machine. Demir is the guy from TopTal. He's playing with these guys. Woohoo! And I've heard he has some awesome demos, so please welcome Demir, who will be flying drones with us.
Hi, everyone. Thanks for coming in very large number. I hope that you're here because of the presentation, not for the closure. I come from TopTal. I'm lead technical editor for our engineering blog, and I want to use the opportunity to invite you to subscribe if you haven't already. And today, my topic is all about drones and using JavaScript to program them, considering that this is should be a web development conference anyway. Any web developer can actually play with these things. Before we go into demos, a little bit of theory first, to understand what drones are, how they actually work to be able to automate anything. So the most known thing about drones are propellers, or known as blades. Each is connected to individual speed controller, and actually drones fly by combining different speeds of blades in order to be able to move in space and so on. There is, of course, the central processing unit that uses information from GPS, gyroscope, accelerometer, camera, and all other sensory information that's available to actually synchronize blades and make sure that it works. The least advanced piece of technology is actually the battery always, that limits the flight time. This model is paired Bebop 2, and it has some 20 minutes of autonomous flight when the battery is full with high-definition recording. So how does actually a drone fly? There are a few terms. Synchronous rotation same speed synchronous rotation of all blades is called gas, and it generates lift to either move it up or hover in one place. If you want to move drone back and forth, you're actually increasing speed on the backside propellers, lowering the speed on the front, and the drone will actually tilt and move because all the blades are fixed. They don't actually have their heads to be able to move around. Moving forward is known as positive pitch. Of course, if you want to move backward, you're gonna do the opposite side. Drone is gonna tilt back, and it's gonna fly backward. There is another term called roll, because drone will roll to one or the other side by increasing a left or right side propellers. So there is also a positive roll or a negative roll. So combining these things is actually how drones work and how they fly. There is also another term called yaw, which is a diagonal combination to be able to spin in one place. When programming for drones, you usually end up in one of two silos. Building firmware for drones or building nice and shiny remote controller. This talk is going to be based on the easier side, which is building a remote controller that processes information that it gets from the drone and automates information back to send combination of pitch, roll, yaw, and things to move the drone. If you're playing with firmware, there is a lot of math and physics, and just calculating the speed of blades to stabilize the drone based on gyroscope and accelerometer is really hideous work. So I'm not going to go there, but components of a drone additional are main camera, bottom camera. It has actually a sonar also below to recognize its height when it's indoors. Outdoors is easy. Outdoors, it relies on GPS, actually, so it's easy to lock the position and fly around. The indoor flight is really, risky, I can tell you. So if it gets its own mind, please just cover your heads. It hurts. But yeah, So how to automate it? Automating drones is not actually an easy task. And these guys are probably the most advanced drones. I keep showing this picture all the time. And they're not automated, even though they have a whole bunch of different sensors and ways to do what they're created for. But these guys, for home use, home and office use, are not equipped with anything that can make them that advanced and automated. For example, the drones usually have just one camera. So there is absolutely no way or algorithm that you can apply for a drone to become aware of a 3D space around. There are some experiments where guys from MIT stripped down Kinect and added firmware around it to recognize 3D space and fly through ruins, try to do some for fire departments and so on, but that's still in experimental cases. So even these markers on the stage is actually something that I added last evening. Thing is that I tried my demos here, and this floor is amazing. It's nice black and with no reflections. So drone is indoors. It's using camera to be able to position itself based on what it sees. It does some image processing. And it couldn't see anything, so it started just gliding around, losing control, and even hit the wall over there. So it was a nice experiment. Luckily, one of the cameramen or whoever, I think it was there, the tape that I used to just make some landmarks. So the positioning doesn't matter. It just requires something to be able to recognize where it is. So today's demos are going to be based on JavaScript development, on JavaScript, sorry. And actually, let's start from here. Parrot, the reason why I'm using Parrot is member of Open Drone community, Open Drone initiative, and almost all of their software is open sourced. If you're Android or iOS developer, you can go to Parrot GitHub and download the full SDK to build your own remote controller for Android or Android applications. Their protocol is open sourced, and based on that, I was kind of playing around with it and came up with an idea for this talk and doing things in JavaScript. So whatever you do using these things that I'm going to show you today, you won't break a warranty of a drone. So first demo is just a simple fly-in. How does it work? Actually, let's go to demos right away. How does it work? You connect to their Wi-Fi. Let me just check if it's on. No, it's not. Bebop 2 is Android-based, so it actually has a custom version of Android that creates a hotspot, and you connect to its Wi-Fi. Initial communication is via TCP, and then you get the full the UDP connection. So let's go to start, and I'm going to connect, get some information. I'm just going to say to fly in. So what I'm doing now is I've just sent it the command to take off, hover a little bit, fly forward, increasing the pitch for a couple of seconds, and then hover and then land. So it's very simple, but this demo actually is what you need to automate things. All you need to learn then is using different commands and how moving forward, backward, and so on works. So today's talk is about something more. It's about video and how it all works. Video is actually sent as RTSP stream over a parallel UDP channel. And you can use any RTSP-enabled player on your side to decode the video. There is an VLC demo, but I prefer actually to use just a standard FFplay. Not sure if you heard about it, but it goes in combination with FFmpeg, which is part of the demo as well, so I want to show you. So next thing I'm going to do is I'm just going to show you how the video works. I'm going to tell it to start streaming video, and I'm going to tell it to take off. And then I have this other terminal. We're gonna, and here I am. So, hi. No need for any other advanced programming or whatever. And now I'm gonna just tell to land. Cool. So now you have a way to see on your side, on your controller side, what the video sees. Processing real-time video is, well, pretty time-consuming, and it requires a lot of computing power and so on. So it's actually much easier to just take the video that it generates and save it as array of images or keep overwriting one image. So the demo I created here is based on that. You can do, let me just go to next slide. So you're just taking the RTSP video stream, generating images, saving them on your side, and then you can process images. You can do that by using OpenCV or any other service for that purpose. I actually have a nice demo that uses some cloud computing. So I'm taking images, throwing them back to a service that does analysis and processes things back. So, but first, let's try this. So if I tell it to make a selfie, not selfie. What it should do, it should take off. Hover a little bit, take a picture, land. Oh, my FF play still seems to be working on the other side. But if it goes well, it actually should have taken the picture. No, it didn't. It kept the same picture. I have to kill the FF play over here. So how much time do I have? 5 minutes. OK. Let's just first do some killing. Okay. That's it. 10668. I didn't kill the FF plate earlier. My bad. Now it works. Well, anyway, I'm going to do another demo since we don't have too much time. OK, let's start from here. Just like I tried and posted the wrong image, the old image from today, actually, to Twitter. Not sure if you guys heard about Google Vision, but Google Vision is amazing Google's service where you take an image, throw it back to them through a simple forum post, and you get feedback of analysis of an image. So you get some information about the color, but it does logo recognition, it does landmark recognition, it does face recognition, it does a whole bunch of things in less than a second, which you can then use to react to what the drone sees. So the next demo is actually based on recognizing these pictures. I'm just going to tell it to connect. I'm going to tell it to start processing video. Then I'm going to say to start saving video to an image, to take off. And let's see what the... So it generates this out image every couple of 5 times a second, sorry. But what I'm going to tell it now is to start looking for logos. So if I show it a logo of Football Club Sarajevo, let's see if it likes it. Maybe I should move a little bit closer or so. Let me just see what he sees. Where do I need to stand? Oh, it saw it. So it obviously doesn't like Sarajevo. So. But let's see how it reacts when it sees Željo. Of course, that's not it. I mean, we're in Croatia, so. Moves left and right. Looks like it likes it. And to finish the demo, where are we? All done. So another thing that I'm not going to demo here is a challenge that I've been playing with recently is considering that this is all JavaScript. You can easily take Raspberry Pi. I've been mentioning that in a few other conferences as well. With few tweaks, it actually can run Node.js. And you can either do these things from Raspberry Pi, or you can create a proxy for your remote. And if you can allow a few seconds of a delay, you can use 3G actually connection to connect to your drone and fly it in another city and so on. So once the demo is fully ready, maybe on one other conference I'll show it. Today is just food for thought for any of you who wants to give it a try. Yeah, we had a championship, and that's it. The code is currently on my GitHub. It's closed, but I'll open it later tonight. You have a few more other examples that you can play with it if you are interested in working with parrots. You don't have to get this model. This one's a bit expensive, but there are cheaper models from Parrot that uses the same type of protocol. Don't use AR drone. They're the most popular old Parrot drones because they have old type of proprietary protocol that doesn't apply to other models. I'm open for questions.
Okay, for questions, please raise your hands and keep them up so I can see them. If there are no questions, still people think about some, you can run the demo. That's
what?
You can run the selfie demo.
The selfie demo,
yeah. Maybe they'll be more encouraged to ask questions when they see themselves on Twitter.
Let's see if it's going to work now. Again, I have to do some killing again, obviously. Come on. Do we have time for this thing? No, it should be okay. What's wrong? The famous wording, it worked with me. It worked before. Now, obviously, the Twitter demo is not going to work today, so let's not waste your time.
Anybody came up with a question meanwhile?
Everything clear? Cool. This is the first time. Okay, then that's it. Thank you, guys.